Hey, Wilson,
Yeah?
what is knowledge graph?
Do we need it to enhance our LLM performance?
Oh, and also, do you know how to integrate it with Langchain?
Okay, guys, hold on, take it easy. I will explain to you in detail step by step, start from the theory until how to set up our Neo4j database, and then how to integrate it using Langchain, and of course, all of that we will use an open source LLM. So, without further ado, let's get started. What is knowledge graph?
Once upon a time, way back in 1736, there was a Swiss mathematician named Leonhard Euler who faced a mind-bending challenge: the seven bridge of Königsberg problem. Is there a way to walk across all bridges once, starting and ending at the same place? Euler realized something more crucial. What mattered was how things were connected. So he turned the city's landmarks into dots or nodes and its bridges into lines or edges, creating a neat little network known as the origin of the graph theory.
Story time is over, guys, but hold on. Instead of just thinking about landmarks and bridges, now let's think bigger. So imagine nodes as the entities such as people, buildings, schools, bands, and many more, and then the edges as the relationship between them. For example,
There is Amy, working at a bank and chatting away in Mandarin. Now, us and Brian, also a bank bound who loves fried rice. Oh, there's also Anne, Brian's friend who is fanatic for fried rice too, and also fluent in Mandarin. Sounds a bit tangled, right? But look at the graph we've got. Suddenly, it all starts to make sense. Now, with the idea of nodes and edges, entities and relationship, we have this final graph.
but hey, let's get real. Our world is not just about Anne, Amy, and Brian. It's not just about bands and fried rice too, right? So it's a vast thrill of people, things, entities, and all of those have this spatial relationship. And that's what we call as a knowledge graph.
So once again, knowledge graph is a network of real-world entities and illustrates the relationship between them. Often, we store the knowledge graph in a graph database such as Neo4j database and process it using cipher query language. Neo4j cipher query language includes clauses like use, match, read, return, and more. You can delve into them further with this Neo4j cheat sheet.
Now, let's talk about how knowledge graph empower an LLM. So, using a knowledge graph, you can identify the links between seemingly disconnected concepts. What does it mean?
So February 2024, researchers from Microsoft conducted a research to compare base retrieval augmented generation system or RAG and graph RAG.
They used violent incident information from a news article dataset and they asked a questions. What has Novorossia done? The result, baseline RAG not able to answer it because sometimes using factor similar result is not always effective.
Especially when the query does not provide enough context about its true intent, or when the context is fragmented across a large corpus of text.
You probably have heard about plus in the middle things, and that's the problem. And they proved that GraphRag able to answer these questions because first they will search about the entities which has no foreseer. This allows the LLM to ground itself and then provide a very detailed answer. In November 2023, there was also a research that showed how knowledge graph optimized the search in a SQL database.
The researchers revealed that question answering using GPT-4 with zero-shot prompts directly on SQL database achieves an accuracy of 16%. Notably, this accuracy increases to 54% when questions are posed over a knowledge graph representation on the enterprise SQL database. Okay, so that's the reason why learn knowledge graph our LLM is very interesting and important. And before we go into code, it's better for us to understand how it works. So first in here, we will get the user question, and then we'll pass this user question to our LLM. In this tab, our LLM will also receive a database schema. Database schema means like the entities and relationship that we already stored to our Neo4j database. And the whole process in here, we call it as the graph chain. And then from the graph team, it will generate a cipher query. And then we will run the cipher query to our Neo4j database to get the result. And the result, we will pass it to the LLM. In here, the LLM will pass the result, will create the result into our final answer. And in this step, we'll get the final one. Okay, comes the code. So actually all the code, the data I've already provided in this GitHub, and I already put it in the description. So the first thing that we need to do is just to clone this. So I'll just copy and then go to our VS Code and do git clone here. Okay guys, once done, our next step will be creating a virtual environment. So just go to our folder and then do pip install like this. It will take a few seconds, so I will skip this part. Now let's open the notebook that we have in here. So since we have already installed all the dependencies from the pip install that we've just done before, so let's run this one. So in here, I'll go through, since we are going to use the open source LLM, which is the Gemini, and then Hugging Face and also Neo4j, so I'll go one by one how to get the API key for all this. But before that, we need to create a .env file to save the environment variable and just do this. The Google Gemini API key, so just go with this URL and then create API if you don't have it. And for your Hugging Face, just follow this link and then use new token. But since I already have this token, so just copy and then save our environment variable. And then for Neo4j, actually you can use my Neo4j desktop, but for this, I'll use Neo4j Aura, which is a little bit simpler. So if you don't have an account, you should sign up in here. Okay, so the instance is ready, and now click open. Okay, so in here we have the connection URL, in here we have the database user and also password. Make sure to also copy the connection URL and the database username to the environment variable, the .env file. So right now just copy paste the password and click connect. Now the database is connected, and now the next task is how to connect the Python in here to our database in the Neo4j. So actually Langchain already provide us with a very simple connector, which is this one. Langchain community.graphs Neo4j.graph in here. So just click run, it's all done. Okay guys, so we have done to set up everything, so now let's talk about the data itself. So the data that we will use in here, I will keep it simple. We won't process data from the unstructured format such as the PDF, the text file, no. But in here, we will use from data from Kaggle. So thanks for Manis Kumar for providing this data set. So basically, it is a LinkedIn data set, professional information like the name, the city, and the current company that they work in, the position, and many more. And actually in here, we did a little bit pre-processing to finally get this final data. The next thing is how to insert this data to Neo4j database. So as you can see here, since our data in Neo4j is still empty, the nodes is 0 and the relationship 0, and you can also check it by run this cell. You can see in here, there's nothing in here. So how to input it? So the first thing that we here is by using the cipher query to interact with our database. So I'll explain one by one. Start from here. Load CSV with headers from blah, 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 blah. So actually, it's loading the CSV file from this GitHub repository. And then as row means, okay, read the CSV file for each row. And in here is the cipher query itself. So we know that, okay, in here, name is the entity of name is person. So we make it to define the entity that we have in our database. So in here, it's a little bit different with the previous one, right? So basically, we use for each because if you see in the language in here, sometimes one people speaks many languages such as Roberto Mirola. He can speak English, Italian, French, Dutch, and German. So in here, we separate with this symbol. And this line is talking about the relationship. If you still remember about the explanation about relationship entity, so this one is the relationship or the ages. Just run this one, okay? And let's check it. So now our data is already in the Neo4j database. Check once again, let's reload this. Okay, see, now we have the company, now we have educated ad, country, industrial limits. All of the data in from CSV is already imputed in our Neo4j. Okay guys, now let's talk about the most interesting part of this video. How to operate the large language model to interact with our knowledge graph in Neo4j. So in here, we are using Chat Google Generative AI, Gemini Pro, it's open source, and then the API ensures the parameter that we have saved before in .env file, and in here, we set the temperature to 0. The question is, why we not set it to 0.5 or 0.9? The reason is because in this task, we need the LLM not to do a creative writing, but we needed to translate the natural language to a cipher query language. And then here, the chain with the vanity chain with graph cipher QA chain. Langchain has provided it's very easy to use. So the graph is the graph that we have defined in here, and LLM is the model that we want to use, and for both, I set it to equals to true. What does it mean? Because I want to understand what happened beyond LLM. So run this, and then in here, we have several questions. I've already created a table that contains a pair of the question and the correct answer, so it becomes easier for us to check whether the answer resulted from the LLM is correct or not. We want to know how it's performed, so let's run it. Okay, that's cool. Okay, so now let's talk about the result. So the first questions. List of companies in advertising services industry. In here, it generated cyber and the full context is said, and the result is Toolbox Creative, baked advertising search engine people. That's perfect. And the second question is, a worker who graduated from Simon Fraser University is currently employed at. Okay, I'm not sure why, but the generative cyber query in here look a little bit messy, and that's why there's a null in the context, so yeah. The result is I do not have that information. We fail in here. And then the third questions, where is Paul Lux working? Okay, so in here the general cyber query is correct, and then the full context in here, Toolbox Creative is correct, but I'm not sure why the finished chain in here result I don't know the answer. The fourth questions we see spoken in, which actually, if you remember about the schema of our database, the relationship, there's no spoken in our database, right? So that's why it's no, and I don't have that information. The last one is, okay, the problem is the same. It's not default. Actually, it's kind of hallucinating about relationship, about the properties, about the entities, right? Because we don't have relationship is not default in our schema. So that's why it's also wrong. The answer is 0. The correct answer is 1. Now, let's do a quick recap on the result that we have got before. So in here, we have 2 correct answers and 3 false answers from the LLM, right? And from this result, we can identify some problems. The first one is not being able to accurately translate text into a cyber query. And the second one is hallucinate properties, relationship, and entities. This one is one of the biggest problems of the LLM in generating a cyber query. So what is the solution? We call it as prompting strategies. So in short, we provide examples to our model to help it understand the structure correctly. Similar to how parents guide us when we learn to work, right? More examples makes the models learn and smarter. Now, let's jump to code. So the first thing that we need to do is to create pairs of question and cyber query. So I won't do it manually, just copy this and paste to ChatGPT. Okay, once we got a result, so just copy and paste it to our VS Code. For example, in here, I want to copy these questions. And the most important part is to check once again if the generative query from the ChatGPT is already correct or not. We can do this by go to our Neo4j, copy, paste, and check. Okay, good. We have this name, bagus Satyama. So the generated cyber query is correct. Just do all that and copy paste in here. The last thing that you need to do is to add braces in here, because if you don't do it, you'll get an error. I've already have this one, so I won't use it. I'll use mine to just run this. And then in here, actually, Langchain already provide us with a few shot prompt template. And so prompt template is just the prompt that we want to use, that we will use as a parameter in here. And the example is an example that we have already divided in here. So it will take the top 3 examples from it, and then the prefix and suffix, and here is the input variables, which is question and schema. We'll use it the question and this, and the schema in here. So run this one. This is an example of the prompt. Let's create our second chain and check this. For the first question, the answer is correct. Toolbox creative, baked advertising so until people go. And for the second question, we get a correct answer, which is elastic path. And in here, we got toolbox creative. For the fourth question, the generated cyber query is also correct, and we get here Vitaly Nguyen. And then for the last one, okay, we got the correct answer too, which is 1. So using the prompt strategies will enhance our model. Right now, we have all correct answer. Okay guys, now our job is done, but as I've told you before that I have a bonus for you. So, if you still remember, we have this question. Where do Michael work? And the prompt that we got is, which workers speak French? What industries are workers named Emily associated with? And which workers live in Canada and speak German? So actually, there's no correlation, right, between which workers speak French and where do Michael work. And the reason is this line. So in here, we are taking top 3 from this list. In fact, we have more than 3 questions. So what's the point to just only take this top 3? And that's why we need a dynamic prompt. So to create a dynamic prompt, we need a semantic similarity example selector. So basically, if we calculate which one is the closest between the question and the list that we have. So the first one that you need is the Hugging Face embeddings and then the neo-fortune factor. So previously, we are taking the top 3 questions from the examples list. Now, we will use the example selector to create a dynamic prompt. If we run this, so where do Michael work? What companies do workers named John work in? It makes sense. Where do workers named Alice live? And what industries are workers named Emily associated with? So right now, the generated prompt is more dynamic and we're not just take top 3 from our list.
Okay guys, so we have learned about what is knowledge graph, why is it important, how to set up our data in Neo4j database, how to chat with our data using Langchain and open source LLM, and last but not least, how to enhance our model. I hope this video is useful for you guys, and if you have any thoughts, questions, or comments, so please let me know in the comment section below. Bye bye.